Hi students, I want to go over harmonic motion with you. Now this is going to reappear probably in calculus as well as, most definitely in calculus, as well as in physics, because trig functions, as I wrote here, are really useful in describing motion of a point on an object, whether it's vibrating, oscillating, rotating, or just moving in any types of waves. Now the at rest, as you can see, right here we're going to be working with something that's oscillating, and the at rest is called equilibrium. And your maximum displacement is your highs and your lows, your maximums and minimums. So here's the equations I need for you to write down. It can be described in two ways. One is D is equal to A sine of omega t. You can say W or omega t. And then D is equal to A cosine omega t. Now the at rest is the equilibrium, and which we're going to call midline. So I should put that down. That's midline. Okay, the absolute value of A is a displacement, which is your maximum and minimum. The period is the time it takes to complete a cycle, which we find the period by doing 2 pi over omega. So if you're used to B, you see that relationship there. However, with this, they're usually more concerned with frequency. Now the frequency describes a number of complete cycles per unit of time. It's the reciprocal of the period. So you'll see it as 1 over the period sometimes, but that is the same thing as omega over 2 pi. So when you're asked, if they don't say frequency, but they rather ask for the time that's required for one oscillation, that is the period. So let's do a little work, see if we can, I can show you how to do some problems. First, I'm going to show you how when you're given an equation, identify, in this case, the maximum displacement. That will be super easy. The frequency, the value of displacement when the time is 4 seconds, and the least positive value when the D is equal to 0. So I'm starting with this, when D is equal to 6 times cosine 3 pi over 4. And here, obviously, your maximum displacement, which is A, is going to be 6. Easy enough. And now for your frequency, I want you to write somewhere where that's omega over 2 pi. It's a reciprocal of the period. So here, our omega is 3 pi over 4, right? Divided by 2 pi. So if I go 3 pi over 4 divided by 2 pi, well, I know it's really just going to be 3/4 divided by 2, right? 3/4 divided by 2, because that pi is going to cancel. So what is half of 3/4? It's 3/8. Okay? The pi canceled. So I really should write that right here. So for C, when they're asking the value of D when T is equal to 4, you're simply using that as your input. So if I said D is equal to 6 times cosine 3 pi over 4 times 4, because that's my time, all I'm asking for is 6 times the cosine of 3 pi. Now what is a cosine at 3 pi? At 3 pi, isn't that -1? It is. And -1 times 6 is -6. So you simply use that as an input. Okay, on this last one, it's the least positive value when the displacement is 0. Let me explain that. Or the displacement is midline in some cases. So let me show you something. What they're asking, you know how this repeats and repeats? They're saying, what's the least positive value? Because there's an infinite number of times that happens, but what is the least positive? So I'm going to show you how to do this algebraically, and then in class I'm going to show you how to do it with the calculator because it's so much easier. Okay, so here's the deal. Okay, if you caught that glitch, I messed it up. So if I put D is equal to, I'm going to rewrite this, cosine of 3 pi, look at that, over 4t, and that's equal to 0. The first thing I'm going to do is get rid of that amplitude, and I'm going to divide both sides by that. It's kind of distracting because it doesn't have any bearing. The amplitude doesn't have any bearing on the frequency of the wavelength, right? or the time, it doesn't matter. So I'm going to get rid of the amplitude by dividing it out of both sides. This is a time when you have to think, and it gets better. So you really do have to practice a few of these before it actually clicks. When is the cosine 0? So I'm going to list when the cosine is equal to 0 at pi over 2, that top of the circle, right? And then 3 pi over 2, 5 pi over 2, etc. But when is the smallest? This is the smallest, right? So what I'm going to do is this. 3 pi over 4 times t, the cosine of 0 is pi over 2. That's the smallest one. So now I'm just going to multiply both sides by the reciprocal right here. So I say t, new color, t is equal to pi over 2 times this reciprocal of 4 over 3 pi. The pi is going to cancel, and the 2 is going to, so it's going to be t is equal to 2/3. That's the smallest one. So I just kind of negate those. I just remember the smallest one. If this was a sine, then I know that would happen at 0 degrees, right? At 0 or pi, 0 pi, 1 pi, 2 pi, etc. So in class, we'll do it algebraically, but in class I'm going to show you how to find that on your calculator. Okay, now I'm giving you an equation, and I'd like you to fill all this out with the maximum displacement, frequency, blah, blah, blah. Please try that using your notes you just took, and I'll give you the answers in 3, 2, 1. So pause it. Now here are my answers. Let me show you how I got each one. There is my amplitude on number 4, or maximum displacement. If I plugged in this 8 pi over 2 pi, you know, you do omega over 2 pi, 8 pi divided by 2 pi was 4. On the next one, I just plugged in 4, the cosine of 8 pi times 4, that's 32 pi. So the cosine at 32 pi is simply 1. It's coterminal with 2 pi. So times 4 is 1, and that's where I got it. Here's the hard one. When I did 0 is equal to 4 cosine 8 pi times t, I got rid of the 4. It's irrelevant. And the cosine at 0 is equal to pi, cosine is 0. The inverse cosine of 0 is pi over 2 is equal to 8 pi times t. So I just multiplied both sides by 1 over 8 pi. That became just t times pi over 2, and it became 1/16. Okay, write this example down as well, because what if I give you the attributes and I want you to give me the equation, and in this case I'm going to say the sine graph. So I'll tell you what, if you saw it, you could look at it just to see if it started at midline or the crest or trough, but I'm going to go ahead and tell you it's a sine graph. So here, the amplitude is 1/16 and the frequency is 70 oscillations per minute. Okay, so you're going to say, we're using this, D is equal to a sine omega t. So this is what I'm trying to fill in. So the D is equal to, the amplitude is 1/16, so it goes right here, and you'll write the sine if frequency is 70 oscillations per minute. Now remember, frequency is equal to omega divided by 2 pi, right? So I'm going to replace the 70 with the f, omega divided by 2 pi. So I'm going to multiply both sides by 2 pi to find out what w is, or omega, sorry, 140 pi, right, is equal to omega. So that means I'm put 140 pi times t. And that's what you do. Since frequency is omega, I gotta quit doing that. All right, we're done. You take care.